All right, well, hello and welcome to everyone who just got joined into today's Power Hour, where we're going to be talking about internal door diagnostics. I think a lot of folks would be surprised at just how much is going on behind those door panels these days. We have some seasoned technicians out there that have dealt with all this before, and they've seen the progression. But we also have a lot of new technicians out there that haven't dealt with this all before. So we're going to kind of do an overview of what's going on within that door, as well as behind that dash, so that all the things that are going on in some of these panels and some of these switches are able to work the way that they're supposed to work. So we've got a lot to cover in a very short period of time, but we're going to get around to it. We're going to try to give you some insight into what's going on behind that door for internal door diagnostics and your future repairs that are going to be coming through the bays. So with that, I'll head over to the bench and we'll see you there. All right, so today we're going to try to look at a few important components in these modern vehicles, right? Things like the door lock actuators, power window motors, the master driver window switch, and even the body control module, as well as a few other modules that are in the system here. Because these components don't really operate independently. And on these modern vehicles, they rely on a lot of network communication modules and sensors to work together. So we are going to cover the basics of how each of the parts work, how they interact with each other, how they commonly fail, and some tips here to help diagnose them using some simple and hopefully very logical steps. So we'll start with the door lock actuator. Right now, this is simply put, the DLA is an electric device inside the door that physically locks and unlocks the latch. Now it's going to receive commands from things like the key fob, the remote, keyless entry, or the keyless entry sensors, driver door switch, and ultimately the body control module. Now, most of these are going to be a small reversible electrical motor or a solenoid with gears, and the body control module or the switch is going to command the doors to lock, and the motor is going to drive the gear set in one direction. When we go to unlock, it's going to reverse the polarity and then spin the opposite direction. Now, most of these modern actuators are actually integrated into the door latch assembly, so keep in mind, in the event of a failure, you're not just replacing the motor, you're actually replacing the latch mechanism and the motor as one complete unit. Now, we do have some fairly common failure points with these door lock actuators. So we have things like motor brushes wearing out, pretty common. We have things like plastic gear failures. Now, with plastic gear failures, this is going to be common on just about any manufacturer, because you got to think we're going to have millions of vehicles on the road being built with these door lock actuators, and they want to lessen the cost of every component that's possibly put on the vehicle brand new. So plastic gears are one way that they do that, and these can fail pretty easily. Then we also have moisture intrusion. You're going to see a pretty common theme with that talking point. Moisture intrusion is going to be a big deal with everything internal door at this point, because there's just so much technology behind those panels. We can also have a pretty big issue around high resistance in the wiring at the door jamb harness. We're going to look at that a little bit more later on, but that's also a very common reason we can see things with these internal door components failing. And then, of course, we can have internal latch or micro switch failures. I mean, it's an electrical / mechanical component. It's going to have some failures at some point. And so some quick diagnostic tips here on door lock actuators, and this is not always perfect, but sometimes just listening for the actuator noise, right? Does it sound weak or completely silent? We've done this with fuel pumps for years, and that can kind of give us some clues every now and then, but also checking for voltage at the actuator while commanding it with a scan tool or the switch itself. And it's a good idea to wiggle test the door jamb harness for any intermittent power or ground issues at the same time, as this is actually far more common than you might expect. And then, of course, scan the BCM codes. Many of these newer modern vehicles will now log lock motor circuit high and low codes, right? And one last thing to note here on DLAs, they all must meet Federal Motor Vehicle Safety Standard requirements for door ejection safety. So if you are replacing one of these, you want to make absolutely sure that they meet those FMVSS requirements. So moving on, we now have the power window motor, right? And this is really just another reversible DC motor. It's usually driving a cable regulator or a scissor regulator, and to raise and lower the glass, they're controlled by switches or, again, automatic up-down smart modules. Now, the polarity of power delivered that's going to be going to the window motor is going to be determined by the direction, right? So positive, negative is going to make it go up. Negative, positive is going to make it go down. And these newer modern vehicles will often integrate the window brain, if you will, into either the switch itself or a door module. Now that's going to allow for like things like pinch protection, auto down, and window initialization as well. So with these, we also have some common failure points. We can have worn motors causing slower stuck windows. That's pretty common. We can have regulator cables fraying or binding, or we can even have auto function failures due to just a lost initialization. We can also have broken wires in the driver door jamb, or we can also end up finding carbon buildup on the switch itself. And so a few diagnostic tips here would be like kind of like the door lock actuators. Check the motor operation for noise if possible, right? And also check the power and ground at the motor while pressing the switch. Or you can load test the circuits as well, because voltage may actually appear present but then drop under load. And it's also always a good idea to check for window initialization procedures after any battery disconnect, really regardless of what you're working on. The last thing we want is a comeback over a simple procedure we can likely resolve with our scan tool. So, double check that after you've disconnected a battery. And if possible, use bidirectional scan tool controls on the vehicle with door modules, if it has door modules, to verify the operation. All right, so now on to the window switch itself. And let's think about this as kind of the main command center for all the windows and even the door locks most times, power mirrors, and even puddle lamps, depending on the vehicle and the features that it has. Now, these can communicate in different ways. Some are direct wiring to the motors, but those are primarily found on older systems. What we typically see now on newer systems is where they're going to communicate over the network through either the body control module or the door control module. We'll talk about that more here in a minute. But, they can work in a very simple way or a more complex way, depending on the vehicle and the features. Right? They can either be a simple mechanical switch set, or in some cases, they're actually a smart module that sends the commands digitally across the network. And on modern cars, pressing the switch, remember this, doesn't directly power the motor. Instead, it just sends the request to either the, again, body control module or the door control module, which is then going to energize the motor, right? And a quick tip here, because of this style of communication, a bad switch can look like a motor problem, and a bad body control module or door control module can look like a switch problem. So thorough inspection and diagnosis are definitely recommended here as well. Now, the most common failure points here, again, worn contacts from heavy use. We see this a lot on fleet vehicles. And then once again, moisture intrusion. It's a big factor, along with broken internal logic boards. Sometimes just one hard slam of the door can be enough to damage not only the components inside the door, but the switches as well. And we can also run into failed auto up-down sensor calibrations, something we can often just quickly verify, with a scan tool, or maybe even correct with the proper scan tool. And of course, like any other electrical component, corrosion on the connectors. A lot of common themes when it comes to the normal failure points from, these types of components. Now, some diagnostic tips here. Try and check the switch output using a scan tool. Many are now going to show the switch status live, which is a very nice thing. We can also try commanding windows from individual door switches versus that master switch. And I know that seems like a simple thing, but it's often forgotten when we're focused on a specific door or a specific component in the door. We should always also inspect for any liquid damage that may be affecting either the connectors or the logic board. And if you have the ability, check for network communication faults. And you're going to find these very commonly on vehicle platforms like Ford, GM, and Mazda. So that's the switch. Let's move on to the BCM, the body control module, which is going to be that main controller for most body electrical systems. Now it's going to receive inputs from things like the switches, fobs, and sensors, and it's going to output commands for things like the locks and the window motors that we just discussed. So they're often the brains behind smart door modules as well. Now, the body control module is going to act like the hub of the vehicle's body network, right? And instead of sending power directly to the actuator, it actually sends a digital command to smaller modules in the door, or it triggers relays depending on the design that it has. And so things like door lock commands, keyless entry, security systems, window auto functions, interior lights, all of these are going to be coordinated through that BCM. And the BCM is also going to monitor circuit faults. So for example, if the BCM detects an overcurrent window motor, or an actuator with too much resistance, it can actually disable the output and store that DTC for a later review by a technician that may be working on a trouble code that's coming into their bay. And so with these, again, we have some very familiar and common failure points as well. Some you've probably already dealt with in the past, things like internal relay failures. We can also have software corruption in a body control module. Definitely connector corrosion or bent pins. And then, of course, water intrusion yet again here, and often found leaking from things like the windshield, sunroof, and the cowl drains. And we can also have a lot of network communication faults with body control modules. So some quick diagnostic tips here. Always check the BCM DTCs first. With these newer vehicles that are on the road, we're getting a lot more data and functionality through these modules, so it's likely you'll find codes that might actually lead you to a good starting point in your diagnosis. If you can, watch live data to see if the body control module is actually receiving the switch inputs, or you can use bidirectional controls to command the actuators. Also check grounds, because body control modules are extremely ground dependent. And as usual, if you can, inspect for water entry, especially below the dashboards. And we can't forget about the ECU here. Now, we know that the ECU is the main controller for the engine and powertrain. It manages fuel delivery, things like ignition timing, throttle control, emission systems, and engine performance and safety as well. So, when we think about ECUs, a lot of times we assume it only handles the engine, but the ECU is actually deeply tied into almost all of these modules on the vehicle. And while that body control module is going to take care of things like the functions of the windows and the locks, that ECU is going to provide the vehicle's main operating context. So, things like the ignition state, the vehicle speed, the load, the charging system status, and even security authorization. In these modern vehicles, the ECU is not isolated. It's part of the network of modules that are constantly communicating. And these body functions, and especially certain body functions, will not activate unless the ECU gives the okay. And it's important to remember here too that the ECU shares data over the network to allow or restrict body functions. And it provides a lot of information that the BCM really needs to make accurate decisions. So some good examples of that BCM influence would be things like the ignition state. The BCM uses ECU ignition data to decide whether the windows should operate. Many modern vehicles disable window functions when the engine is turned off. It also looks at vehicle speed data for door locks, because auto locking is going to get triggered by vehicle speed data from the ECU. And the BCM is going to use that information to lock the doors at around that 10 to 15 mile an hour range. And that's why when we take off after starting the vehicle, usually rather quickly, the doors will all lock and sync. Now, we also have the security immobilizer authorization going on between the two at all times. The ECU and the BCM they're exchanging encrypted data, and the BCM often will not unlock or power certain circuits if the ECU reports an unauthorized key or something like that. And then a big one here, this is a big cause for misdiagnosis as well, is the charging system and the voltage state. If the ECU detects low voltage, it can signal the BCM to disable things like the auto up-down function of the windows, power sliding doors, and even the power liftgate, purely to protect the battery from dying. So, going into any diagnosis within these systems, you should always include a charging system and a battery test. And so essentially, the ECU is continuously sending data like speed, ignition mode, engine status, and security status to the BCM, and then the BCM then uses that information to control things like the door locks, window motors, and the switches. And without that data from the ECU, many of those body functions would either fail completely or at the least, very least, behave a little strangely. And so we can see the BCM is very dependent on information from the ECU, but the ECU also depends on the BCM for critical real-time information. So things like keyless entry and push-to-start systems. The BCM verifies the key fob and sends authorization to the ECU, and then the ECU allows the engine to start. Without that BCM approval, you're not going to get a start. And we also have to consider things like crash detection and door ajar signals. The BCM actually provides door ajar state to the ECU, and then the ECU uses that information to adjust things like idle behavior, high voltage shutdown in electric vehicles, and EV drive inhibit when the door is open. And then there's also load management to consider, because the body control module reports things like electrical loads running from window motors. And the ECU can then use that information to adjust idle speed or even charging output. So I think it's fair to say that these systems are very dependent on good communication and properly working modules, both in the door itself as well as in the dash. And so some common issues where the ECU affects the door or the window operation. If we have a low system voltage, we can see where the BCM might disable auto functions. If we have CAN bus faults, we can see where windows and locks might become inoperative. If we had an ECU replacement requiring any type of programming where the programming failed, we could see a no crank or a no unlock situation. And if there's a security key mismatch, the BCM is just going to refuse to power the lock or unlock circuits. And then, of course, if we have a loss of speed signal, the auto lock function will also be disabled. And so, oftentimes customers come in thinking they have a bad window motor or a bad window switch, but the real problem is actually upstream. Maybe it's a low system voltage, maybe it's a CAN network fault or a mismatch between the ECU and the BCM. And these modern vehicles, communication issues are going to be a huge deal when it comes to body features and whether they work or completely shut down. So if we put it all together, a modern system is going to look a little something like this. The command is requested by the driver via that, master driver window switch. The switch is going to check in with the body control module. The body control module is going to get a confirmation from the ECU that the conditions are right. It's ultimately going to send the command to the appropriate component, and whether that be the DLA, the door lock actuator, the window motor, or the power mirrors, either way, this is all happening in milliseconds. So communication throughout the system is very critical. Now that's our typical modern system, but it gets a little more interesting with the newest vehicles on the road today, because manufacturers have adopted and are increasing the use of yet another module, the DCM, or the door control module. And so as these vehicles have evolved, door systems have become way more complex, and they have all these new things like auto up, auto down windows, folding mirrors, lock logic, child safety lock management, all these things, right? And so instead of running 20 plus wires from every switch back to the BCM, engineers have started using the DCM to consolidate everything right at the door. Then only a power and a ground and maybe a couple of communication wires are needed. So what is this DCM? It's the same thing as a BCM in a way. It's a small module or a control unit located inside the door itself, and it functions as that local brain for the door. So instead of the BCM directly powering or monitoring every switch and motor, like our previous example, the DCM handles all the real-time door functions. Now, this design reduces a lot of wiring, complexity, and it improves response time as well, especially for features like one-touch windows, mirror controls, and the lock logic. Now, the DCM has direct control over several components inside the door, such as the power window motors, door lock actuators, mirror adjustment motors if you got them on the vehicle, courtesy lights, and even puddle lamps, and then local switches like the passenger window switch. It also monitors a lot of position sensors, current draw, and limit inputs for safety features like pinch protection on the power windows. And believe it or not, DCMs fail more often than people might expect, mostly because of their harsh environment. You got heat, you got vibration, moisture finding its way inside the door, and so we have some pretty common failures on these as well. And most of those common failures we've seen before. We have things like water intrusion. We have corrupted firmware, which is pretty common. Network communication dropouts. That's also very common, unfortunately. Power and ground faults at the door harness. We've seen that come up a couple of times already. We're going to see it again. And then we can also have, again, connector pin corrosion. Anytime we have a connector or anything electrical going on, there's that possibility that we can have connector pin corrosion as well. And sadly, it really only takes one good rain with a window down to create a lot of havoc with things like this and all of these system components. And it's important too here to note that a failing door control module may mimic a bad switch or a bad motor. So identifying the network behavior is very crucial. So what are some good starting points to help maybe isolate the door control module faults? First, again, check for DTCs in the body control module, as well as the door control module if the module is listed and present. Many modern vehicles will now actually log communication codes when a DCM is offline. See if we can command test with the scan tool. If the window or lock responds to a scan tool command, but not the switch or the DCM input may just be bad. Observe network activity. A quiet or a noisy bus line can sometimes also indicate wiring or module failures. And then also inspect for the door harness at the hinge. Broken or frayed wires and that rubber boot cause about 50% of the DCM related issues. And then last but not least, look for moisture inside the door. Even minor water intrusion can cause intermittent faults. Now, if after all of that, the DCM does not wake up, does not communicate, or sends no output or actuator drive when it's commanded, it's very likely going to be the root cause, and you might need to actually replace it. So, all that said, how does the DCM communicate with the network? Well, it's very similar to our earlier example, right? The DCM communicates with body control module, and in many systems, the master driver door switch communicates through the DCM and not directly to the BCM like before. The DCM sends the BCM status updates like lock and unlock request, window request, door ajar status, and then the BCM then determines if an action is allowed and sends permissions or commands back to the DCM for operation. But remember here, the DCM executes the motion. It's still the BCM that's authorizing it. So let's pull the ECU from the screen here for a second. We're going to tuck it up in the corner. We still have that ECU, BCM, constant communication going, so it's still there. But I want to focus on the flow of how these more advanced systems operate, and based off of a very common request as well. The request being either a lock or unlock, lock in this situation, and the routine with the DCM in the system. So here's how that typical door lock command travels. The driver presses the lock button. The master switch sends a request to the driver door control module. The DCM then sends the lock request to the BCM that is still communicating with the ECU. And then the BCM validates the inputs on things like speed, death status, and ignition state. And once everything agrees and the conditions are met, that BCM sends the lock command back out onto the network, and each door's DCM activates its own door lock actuator at the same time. And this is going to ensure that all the doors lock in sync, and prevent any unauthorized commands. So with all that said, we can condense it down to a key point here, and that is that these systems rely on far more components than in decades past. And when diagnosing them, really a top-down approach is always going to be the best. Start with the module that controls the system, either the BCM or the DCM. Look for codes or live switch data, whether maybe it's available. And if the module is seeing your command, but nothing happens, the problem is likely downstream, like the motor or maybe the actuator. If the module isn't seeing your input, the problem is likely upstream, leading to the switch or possibly even the wiring. And to give you an example of that, we actually have a case study that brings it all together and gives us yet another common issue within these systems: searchable and easily found information. So we have a 2010 Toyota Camry, 2.5 liter with 172,000 miles, and the customer had multiple concerns, all of which involved the driver's window and the lock switch controls. Now, they were unable to lock or unlock the doors and could not control the other window positions, and the auto up-down function on the driver's door was also inoperative. I think we could all agree it sounds like a bad switch, right? Well, the technician was able to verify the concerns and noted that he was able to move the driver's window as long as the switch was pulled or pushed down and held. No auto function. Well, we'll see here, this is where it starts to get a little silly. Consulting the service manual for the components and the operation of the windows was pretty disappointing. Very little information was available, and the components involved in all the window operations were the individual door switches and motor assemblies. Now, service information stated that the individual window motors receive switch signals and then change these signals into motor activation. And as a result, window position changes. So it also stated that the motors have an ECU incorporating a Hall effect integrated circuit to detect window position and jamming. And service information also listed all of the Windows control functions. Unfortunately, though, it did not state how any of these functions were accomplished, just that they were there and that they were possible. So things like the manual up and down, the all-door auto up and down, window locks, jam protection, remote control, key-op operation, diagnosis, and fail-safe. So the technician decided to examine the wiring schematic for the power window, the master switch, hoping to gain some insight. And it turns out that this switch was far more than just a switch. It was actually a module. And as a module, it communicates with the main body ECU. So hoping to understand the circuit operation, the technician used his picoscope to monitor these three circuits while attempting an auto down command. Now the window moved, downwards only when the switch was held in the down position. And from this test, he learned that the up and down circuits are normally at battery voltage. So when the window was commanded down, the window switch would apply ground to the down circuit, and as the window moved downwards, the average current was 1.3 amps. So he next attempted the auto up command. And again, the window moved upwards only when the switch was held in that up position. So when the window was commanded up, the window switch would apply ground again, but this time to the up circuit. And as the windows moved upwards, the motor's average current was again 1.3 amps. So the technician decided to also use a schematic to learn how the door locks were supposed to work. Now there was no direct connection, from the master switch to the door locks. Instead, the window switch used the LIN communication bus to request door lock activation from the main body ECU, similar to how that switch communicated with the BCM or the DCM in some previous examples. Only here the switch is in the module itself, or the module is the switch itself. So these observations led him to decide, hey, let's check the main body ECU for codes. And sure enough, he found a B1206 that was stored in the module. Now the code was current, so this meant that at this time, the main body ECU could not communicate with the power window master switch. So the technician then used his lab scope to check the LIN circuit at 2 points, at the power window master switch and at the main body ECU. He found a good LIN signal at the main body ECU, but a flatlined LIN signal at the master switch. Now the main body ECU is the LIN master in this network, and the master switch is a slave. So his findings indicated an open circuit somewhere, and this leads us to one again of the most common issues facing these systems today, the door jamb, where the most likely location for open circuit was in the boot between the door and the body pillar. So the technician peeled back the boot and found that the LIN wire had failed due to the years of opening and closing of the doors. So now you see why I mentioned this multiple times. With a simple wiring repair, this problem was fixed and the customer concerns were resolved without even the need for an actual part replacement. And now here's a tip for those vehicles you do have a problem with, finding good information for: save your data. The technician here, after the repair, scoped the signals one last time, not only to verify, but to document the repair and then have a good known capture of the system working properly and for future reference if he had something like this come up again. And so in summary, modern vehicles rely on a network of switches, motors, and modules, and the BCM to operate something as simple as a window or a door lock. And when we're diagnosing these systems, we need to think logically. Did the BCM get the command? Did it send the command? Did the motor receive power? And is the mechanical part working? Because most of these components typically fail in very predictable ways, and with a structured approach, you can diagnose them pretty quickly and pretty confidently most of the time. So before we go, I don't want to forget to mention that we do have some additional resources available to you, like our YouTube channel, the Standard Brand YouTube channel, where we have hundreds of videos now, a lot of good instructional videos, installation videos, and tech tip videos, even around things like these door lock actuators and window motors and things like that. And again, that's a great resource we can use, as well as other categories or other components you might be working on. Then also don't forget standardbrand.com, where we have some really good views of all of these components. So I think it's over 1,100 of these door lock actuator components themselves within the category on the standardbrand.com page, where you can get great views of them. You can see pin connectors. You can see exactly what you're looking at and make sure you're verifying which part you're looking for. And, there's a lot of other categories on there where, as well, where you can get some great information training wise, and then also, get yourself registered for upcoming power hours in 2026. And with that, I'll say again, thank you all for being here. We'll see you next year for an all new lineup of power hours coming to you, and hope you have a great rest of your year, and we'll see you come January.